Okay, let's talk about nomenclature of cations. Okay, there are a couple of different kinds of cations, and um, naming them properly requires being able to look at them and recognizing the difference in the different types of cations. The first group are the ones that I'll usually refer to as transition metal cations. Um, but to be honest, if you look at the periodic table, it looks like this. There are a group over here in group 1 and 2. These guys are going to be special. We'll see later. The group 1 and 2 are special. And so when I say the transition metal cations, I mean all of these guys over here. Okay. But there actually are a couple over here, not very many. Lead and tin and bismuth. A couple others. Lead and tin are the only ones that are really very common. Uh, and also down here in the lanthanides and actinides. Okay. So when I say transition metal cations, I really mean the ones that aren't in group 1 and 2, right? And that's 99 times out of 100. We're talking about these guys over here in the D block, those transition metals. But what I'm saying about the transition metals also includes a few metals. There are only half a dozen or so metals over here in the P block, and metals down here in the lanthanides and actinides. It's just that you won't see those quite as often. All right, we'll look at us and ic suffixes used in nomenclature. We're going to look at metals that have only one common charge, and that's really important. Uh, those include the alkali metals, the alkaline earth metals, and a couple of other metals that are special cases, and there are 4 of those. We'll see those later. And then we'll look at polyatomic cations. There are only 2 of those, which is nice. All right, so the first group is the transition metals, and again, a couple of there in the P block and the lanthanides and actinides. But usually we're talking about the transition metals. And what's important about these is that metals in general, when they lose electrons to form positive charges, they can form multiple different kinds of ions. Right? So for example, iron can either lose 2 electrons to acquire a +2 charge, or it can lose 3 electrons to acquire a +3 charge. For that reason, we can't just say iron ion, because these 2 things are different, and if we just say iron ion, it wouldn't be clear whether we were talking about the +2 or the +3. So when we name ions of transition metals, we have to take that charge and include that in the name so that we'll know which one we're talking about. And we do that using Roman numerals by writing the name this way. This first one we would call an iron 2 ion, and the second one we'd call an iron 3 ion. And that's really nice because if you're looking at the name of an ion and you need to know what the charge is, which happens quite a bit, for the case of these ions, it's really, really simple because the charge is right there in the name. All right, so when you see the name iron 3, you know that it's got a +3 charge. And this is generally the case for transition metals. Vanadium, for example, um, vanadium has several common charges. Vanadium exists as a 2+ ion, or a 3+ ion, or a 4+ ion, and sometimes even a 5+ ion, right? So in describing these, you would call this a vanadium 2 ion. This would be vanadium 3. I'll go ahead and write it, even though you know what 3 looks like. Vanadium with a 4+ charge. and the 5 plus charge. Okay. All right. So for these metals, the charge is included right there in the name, and that's very important. In fact, the name of the ion would be incorrect if you didn't include the charge, for the reason we mentioned before. If you just said vanadium ion, we would have no way of knowing which of those different ions you were talking about. Okay? So for transition metals, it's always essential to include the charge right there in the name in Roman numerals. Okay, now there's an old terminology which is no longer considered standard, right? But you'll still see it fairly often, and this is the us and ik nomenclature, where us and ik are used as suffixes, and these are only used in cases where the metal has 2 common charges. And of course, if you're not really familiar with the metals, it's hard to know which ones have 2 common charges, and it's also hard to know what those charges are, right? But iron, for example, let me back up a little bit. The way the us and ik nomenclature is used is that the us suffix always refers to the ion with the lower charge, and the ik always refers to the ion with the higher charge, regardless of what those numbers are. So us does not always mean +2 or +3 or +1, and ik does not always mean +2 or +3 or +4 or whatever. It's just that for that particular atom, whatever its common charges are, us refers to the lower one and ik refers to the higher one. So for example, as we had on that previous page, iron only has 2 common charges, either +2 or +3, right? And the correct name for these, the name that I will use and the name that I would like you to use, is iron 2 ion and iron 3 ion. But you will still see, fairly commonly actually, the 2+ iron referred to as a ferrous ion, and the 3+ as a ferric ion. In fact, I can go in the stockroom right now and find bottles on the shelves that are labeled ferrous sulfate and ferric chloride and things like that. So it's good to be familiar with that, because even though it's not considered standard, it's still actually fairly common. The downside of it is, I guess there's a couple downsides, but one of the biggest downsides is if you don't know what the common charges are, there's no way that you can use it, and that requires a lot of extra memorization. So I wouldn't expect you to know that iron is commonly +2 or +3, and you don't need to know that because the charges are right here in the name, right? But if you knew that it had 2 common charges of +2 and +3, then you know this was a ferrous and ferric, right? So we can do the same thing for copper, for example. Copper has only 2 common charges. There's a copper 1 ion, and there's a copper 2 ion. And so just like with iron, you will sometimes see copper 1 referred to as the cuprous ion, and copper 2 referred to as the cupric ion. Right. And you'll see these things also when you use the us and the ik nomenclature, the roots refer back to their Latin names, which again is also something that makes them a little bit confusing. So I really want you to use this nomenclature. That's the correct, acceptable way to do it. I mentioned this just because even though it's not standard anymore, you will still see that nomenclature from time to time, and I just wanted you to be aware of what it was. All right, there are several metals that, unlike the ones we've talked about so far, instead of having multiple different possible charges, they only ever have one charge. And because they only have one possible charge, we don't include the charge in the name. And the first group of those are the alkali metals, that is group 1. So if you look at the leftmost column on the periodic table, those are the alkali metals, those are the group 1 metals, and those will always, always, always have a charge of +1. And because that's the case, we have an ion like this. We don't need to name this a lithium 1 ion because lithium is in group 1, we know that it is always going to be +1, and therefore we don't need to include the 1 in a Roman numeral. So instead we would just name this a lithium ion. And the same thing is true for sodium, potassium, rubidium, cesium, francium, all of those in group 1. And so there are two things that are important here. One is if you are naming it, if you have something like this and you have to give a name for it, the first thing is that you need to know that in providing a name, you would call that a sodium ion and not a sodium 1 ion. Because it's a group 1, including the charge here in Roman numerals is not necessary. In fact, it's distracting and kind of wrong. It's not completely wrong, but it's somewhat wrong. It definitely would look funny and would not be considered the best way to name that. The other thing that's important, so that's going from the ion to the name. The other thing that's important is when someone is talking about an ion, they will say sodium ion. They won't say sodium +1 ion, or they won't say sodium 1 ion. They just say sodium ion. And so you need to know that because sodium is an alkali metal, that when someone says sodium ion, they mean that one, and that it has a charge of +1. Even though they haven't told you anything about the charge here in the name, you need to be able to recognize that that has a charge of +1, even if they haven't specifically told you that. Okay. All right, the same thing is true of group 2, which are the alkaline earth metals, except that instead of having a charge of +1, all of the alkaline earth metals will have a charge of +2. Right. So for example, this ion would not be called a magnesium 2 ion, but would just be called a magnesium ion. And the same thing is true for all of these in group 2. Again, that's the second column from the left on the periodic table. And again, as before, the two reasons that's important is, one, if you've got an ion and you need to provide a name, you need to know to name it this way without any kind of without charge indicated in Roman numerals. And the other reason, which is probably more important, is that if you're given the name, you need to be able to reason back and say, okay, that's magnesium. I know that it's +2, even though no one has told me that it's +2 by providing a Roman numeral 2 in the name. All right, then there are 4 others, 3 transition metals and 1 from the P block, which are just sort of randomly selected. And these are things that just happen to have only one common charge. And because they only have one common charge, in naming them, we don't include the Roman numeral. So aluminum with 3+ charge is just called an aluminum ion. Zinc with a 2+ charge is a zinc ion. Cadmium 2+, cadmium ion, and silver +1 is a silver ion. And you won't ever see examples of these guys with different charges, right? They're always going to be +3 for aluminum, +2 for zinc and cadmium, and +1 for silver. Okay. And so again, you need to know that when you write them, you don't include anything here to describe the charge. You leave that part blank. But more importantly, if you see someone write silver ion, you need to be able to say, okay, I know that's Ag+, and I know the charge is +1, because that's one of these 4 ions that have only one common charge. And for these guys, there's really nothing you can do except memorize these guys. Okay, these guys here you can kind of understand. The guys in group 1 lose 1 electron to become +1. The ones in group 2 lose 2 electrons to become +2. That makes sense. For these guys, there's nothing you can do except memorize them. So put them on a flashcard or something like that. These are all pretty common. Cadmium a little bit less than the others, but the other 3 are really, really common. And so you definitely have to know those charges. All right, we also need to look at polyatomic cations. Fortunately, there are only 2 of these. The first one is NH4, which has a +1 charge. And this is the ammonium ion. Okay, this is extremely common, so it's really important that you know this one. I would put NH4, put that one in your flashcards so that you can learn that one. And the other one, a little bit less common, is this one. And this is called, somewhat confusingly, a mercury 1 ion. And this seems a little bit confusing because remember before the charge was indicated as a Roman numeral in the name, and here the charge is +2, but we're calling it mercury 1. All right, so why is that? The reason that we're doing that in this case is because the mercury 1 ion is just most stable when it exists in pairs. And so mercury 1 ions never float around by themselves, so you won't see that ion all by itself. You see the ion only existing in pairs like this, right? So what this symbol means, the Hg2 with the 2+, means we've got 2 mercury ions bound together, and the total charge of the ions is +2. And the reason the total charge is +2 is because each one of them is +1. And so since each one of them is a charge of +1, that's why we write this here as the mercury 1 ion, because each one of the ions in here has a charge of +1. It just so happens that they always travel in pairs. All right, so we've only got 2 polyatomic ions in the cations, but make sure you learn both of those, put those on your flashcards. All right, so let's do a little bit of quick practice and review. I know you probably haven't had time to work with your flashcards on these, but go ahead and hit pause and write names for these, and then unpause, and we'll look at them together and see if we got the same results. All right, so the first one, we actually hit this one several times already, so you probably didn't have any trouble remembering that this one is an iron 2 ion. And because it is a transition metal, we need to take this charge and include it here in the name. All right? And then we've got a magnesium 2 plus ion. But if we look at the periodic table, we see that magnesium is in column 2, right? So it is an alkaline earth metal, right? So that means magnesium ions are always +2. That means we do not, in this case, include the charge in the name, and we just call this a magnesium ion. Okay. Aluminum 3 plus. It's not in group 1 or group 2, but it is one of those that we memorized. You might not have it memorized yet, but it's on your short list of things to memorize. Aluminum is always, always, always +3. And so just like with magnesium, we do not include the charge in the name, and we just call this an aluminum ion. Our next one is vanadium with a charge of +4. Vanadium is a transition metal, which suggests that it probably has multiple common oxidation states. I'm using the term oxidation state and charge interchangeably. They're basically synonyms of one another. So if it has multiple possible charges, then we need to include the charge in Roman numerals. So we call that a vanadium 4 ion. Okay. Now going over to the other side, cobalt, again, transition metal. So it has multiple possible charges. We need to include the charge in the name. So that's a cobalt 3 ion. Lead is not a transition metal. It's actually over there in the P block, a little bit to the right of the transition metals. But because it's not in group 1 or group 2 or one of those 4 special cases that we memorized, that means that lead does have multiple possible charges, and we need to include the charge in the name. So we call this a lead 2 ion. All right. Now, NH4 plus, that's a polyatomic ion, and we've only got 2 polyatomic cations that we've learned. This one is really, really important. And this one is the ammonium ion. And our last one here, K with a +1 charge. K, we should know, is potassium. So this is a potassium ion with a +1 charge. But because potassium is in group 1, all potassium ions always have a +1 charge. It's the only possible charge you can get on a potassium. And so we don't include the charge in the name here. We just call it a potassium ion. Okay. Lovely. Okay, let's try a couple where we go in the other direction. All right, so here are a couple of names of ions. Take a minute, hit the pause button, write formulas for these, and then unpause and see if we got the same thing. All right, so nickel 2 ion. These are actually pretty easy going in this direction, particularly for the transition metals, right? Because it's nickel, so we know it's Ni. The charge is given right here in the Roman numerals. So nickel 2 plus. Sodium ion, you know that sodium is Na. In this case, they didn't give us the charge. There's nothing there in Roman numerals to tell us. So we look at the periodic table. We see that sodium is in group 1. It's an alkali metal. And so that means that sodium ions are always +1. So we can write it this way. Okay. Copper. Copper. First, we need to remember that copper is Cu and not Co, because Co is cobalt. Right? So there's copper. And because it's a transition metal, the charge is given to us right here. So we just have to take that and put it up here as a plus. So that's a copper 1 ion. Zinc. Zinc is Zn. They haven't given us a charge, but zinc is one of that small group of 4 ions we memorized that always have the same charge. And zinc is always +2. So we can write zinc 2+ that way. Silver. Silver is Ag. They didn't give us anything here about the charge, but silver is, again, in that short list of metals that always has the same charge, and silver is always +1. So we can just write silver plus like that. Molybdenum, we don't know the charge of that automatically because it's a transition metal, but they've given us the charge here in the name. So that's just molybdenum 4+. Ammonium ion, this is one of our polyatomic ions that we've learned, and this is really just straight up memorization. But ammonium ion is 1 nitrogen, 4 hydrogens with a charge of +1. And then the last one is the calcium ion, which of course is going to be Ca. Doesn't tell us what the charge is, but if we look at the periodic table, we see that calcium is in group 2, and so calcium ions are always +2. We can write the charge that way. All right, terrific. Fairly short video, good. Cation nomenclature. We looked at these and grouped them into a couple of different groups. The transition metals, including the P and the F block. Really what that means is all of the metals except for group 1 and 2, right? Those are the ones that have multiple possible charges, and so you always include the charge in Roman numerals after the name of the element. We looked at the, again, my things are out of order. Apologize for that. We looked at the us and ik suffixes, right? And these are non-standard. I won't ask you to use those, but you'll probably see them from time to time. And these are for metals with 2 common charges. Us always refers to the lower charge, and ik refers to the higher charge. Then we looked at metals that have only 1 common charge, and these included group 1 and group 2, and a special group of other atoms, or a special group of other metals. All right, group 1, group 2, and then there are 4 others, right? Aluminum, zinc, cadmium, and silver were the others. Right? And then we looked at polyatomic cations. There were only 2 of those, which you need to memorize. Ammonium, which is extremely common, so you definitely absolutely need to know that. And the mercury 2, which, to be honest, you won't see very often. But as long as you're making flashcards, you might as well stick that one on there, because you've only got 2 polyatomic cations, right? Ammonium ion is going to get lonely if you don't put this one in there. All right, terrific. Okay, that's it for cation nomenclature. And in the next video, we will look at anions.